from Agora Math Circle, and today I'll be presenting Math Kangaroo 2019, Level 5 and 6. Problem number 1. Carrie has started to draw a cat. She added more to her drawing using her black pen. Which of the figures below can be her finished drawing? A, B, C, D, or E? Now, if we look at A at first, we compare it to the model from before, and we see that A's nose is too big. B seems to fit all requirements, but let's double check all the rest of them to make sure we haven't missed a minor detail. C's ears are the space between the ears and the head are too big, and D has an upside down triangle nose, and E has a circular nose. Therefore, B is the answer. Problem 2. The Mayan people wrote numbers using dots and bars. A dot is written for 1 and a bar for 5. How did they write 17? Well, first of all, we have to find how many 5s can go into 17. And if we look at it, 15 is the closest multiple of 5 that is under 17. And then 17 minus 15 equals 2. So we would have 2 dots and 3 bars, which means C is the answer. Problem 3. A digital clock in 24-hour mode shows the time 2019. What will the clock show the next time it uses the same digits? Now, we have A, 2091, B, 921, C, 2109, D, 912, and E, 219. Now, for A is not possible because it's not possible to have 91 minutes in the minute section because the minute section only goes up to 60 minutes. Therefore, A is not the correct solution. B is not the correct solution because in order to get B, we would have to cycle back around, and we're looking for a time that stays within this day. C, 2109. 2109 seems like the likely answer, but let us check the last two to make sure that it is the answer. Now, D, 912. D is just like B, where we're trying to keep it within this day, and we're not trying to go back in time in this day. And E, 219. E is just like B and D because we have to cycle over, and we're trying to find which one stays within this time limit that was allotted. Therefore, C is the answer. Problem 4. There are 14 girls and 12 boys in a kindergarten class. If half of the children go on a walk, at least how many of them are girls? Now, the possibilities they give us are A, 5, B, 4, C, 3, D, 2, and E, 1. Now, since we have 14 girls and 12 boys, we add together 14 and 12 to get 26. 26 divided by 2 equals 13, which also equals 12 plus 1. Therefore, we must always have one girl no matter what. Therefore, it is E, 1. Problem 5. The sum of the dots on opposite faces of an ordinary die is equal to 7. Which of the following could be an ordinary die? A, B, C, D, or E? Now, at first, we look at A and we see it's 5, 2, and 4 are the sides we see. Therefore, this cannot be true because in order for it to be an ordinary die, the opposite sides need to be 7, but 5 and 2 are not opposite sides. Therefore, the A cannot be the answer. B shows 3, 4, and 1. For 1, we should use 6, which we would be able to do. 3, we would have to use 4, which doesn't work. Therefore, B does not work. C shows off 4, 3, and 5. So, 5, the opposite of 5 would be 2. The opposite of 4 would be 3, but 3 is on top. Therefore, this cannot be possible either. And D. D shows 6, 5, and 1. For 1, we need 6, but 6 is already here. Therefore, that cannot be true. And E. E displays 2, 6, and 4. For 4, we need 3, which we are able to do. For 2, we need 5, which we are able to do. And for 6, we need 1. Therefore, the answer is E. Problem 6. Which of the following geometric figures is not in the design to the right? A. Triangle. B. Square. C. Regular hexagon. D. Regular octagon. E. Dodecahedron. Alright, so if we look at the diagram, A is present, B is present, C is present, D is not present, and E is present. Therefore, the answer is D. Regular octagon. Problem 7. Laura wants to color one 2x2 square of this figure. How many possibilities are there? A. 5. B. 6. C. 7. D. 8. E. 9. So, if we look at this just up front, we can see that there are 1, 2, 3, 4 2x2 squares on the outside. We have 4 so far. Then we look inside this 3x3 in the middle, and we see that there are also 1, 2, 3, 4. So therefore, we add another 4 to this 4, and we get 8, which also equals D. Problem 8. The smallest odd natural numbers are written on the faces of a die. Tony throws it 3 times and adds the result. Which of the following numbers cannot be the sum? A. 21, B. 3, C. 20, D. 19, and E. 29. Now, it obviously cannot be 20 because when we look at it, when you add any odd numbers to any amount of if you add any odd numbers together, like 3 plus 5 plus 7, and you add them 3 times, this would get you an odd number. Therefore, C cannot be the sum. Therefore, the answer is C. Problem 9. The sum of the ages of a group of kangaroos is 36 years. In 2 years, the sum of their ages will be 60 years. How many kangaroos are in this group? Now, if we look at this, there are 36. It's 36 years. And then in 2 years, it's 60. Therefore, we have to do 60 minus 36, which equals 24. And then we take 24 and divide it by 2, and we get 12. And 12 is the answer, which also means that it is B. Number 10. Michael paints the following solids made out of identical cubes. Their bases are made out of 8 cubes. Which solid needs the most paint? Now, A, if you count it, needs 28. Needs 28 surfaces to paint. B needs 22. C needs 26. D needs 26. And E needs 27. Therefore, A is the answer because A, needs the most paint? Problem 11. A 3-digit number is written on each of the 3 pieces of paper. 2 of the digits are covered. The sum of the 3 numbers is 826. What is the sum of the 2 covered digits? A, 7, B, 8, C, 9, D, 10, E, 11. So, we know that the sum of the 3 numbers has to be 826. So we take that and we add 243 and 1 blank 7 and blank 26. And what we get after that is 376. And then 826 minus 376 gets you 450. By getting 450, we have a tens and hundreds place. The hundreds place in turn goes in the hundreds, and the tens place in turn goes in the tens. But it asks for the sum of the 2 covered numbers. Therefore, 4 plus 5 equals 9. Therefore, the answer is C. Problem 12. Riri the frog usually eats 5 spiders a day. When Riri is very hungry, she eats 10 spiders a day. She ate 60 spiders in 9 days. How many days was she very hungry? Well, we look at it and she ate 60 spiders in 9 days. So 60 divided by 5 should equal 9, but instead it equals 12. So we do 12, subtract 9 from that, and we get 3, which means there are 3 extra 5s left, which means on 3 days she needs to eat 10 spiders. Therefore, the answer is C, 3. Problem 13. Pia is playing with the folding yardstick made of 10 parts. Which of the following figures cannot be formed with this folding yardstick? A, B, C, D, or E? So A can be formed by using the pattern shown here. And if you look closely, this is 9 parts, but you can fold one part on top of another to make it 10. For B, you just outline it like that, and then you get your answer, which means that A and B are both correct. Both cannot be the answer. C could be the answer, but let us check the D and E to make sure that C is the answer. So for D, you go like this. You go up, down, down, and then you go like this. And if you look closely at that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. Perfect. And for this one, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can fold it over itself and go back. Therefore, the answer should be C, because C is the only one that cannot be displayed using this yardstick. Problem 14. 5 equal squares are divided into smaller squares. Which square has the largest black area? A, B, C, D, or E? So you may think you have to count and move all of these, but this is more of a fraction problem. This black area is 1/2. This one is 5/9. This one is 8/16, or 1/2. This one is 13/25, and the last one is also 1/2. So, as we can see here, all of them are 1/2 except for B and D, which are above 1/2. 5/9 is greater than 13/25. Therefore, B is the answer. Problem 15. A big triangle is divided into equilateral triangles as shown in the figure. The side of the small gray triangle is 1 meter. what is the perimeter of the big triangle? So if we look at this, we can see that we can split these bottom triangles into more little triangles, which would result in 1, 2, 3, 4, and 5. So we know the base is 5. Now, on the top, they are trying to trick you. Do not actually go by what they say, because in order to split these into smaller triangles, you cannot go with what they say, because they're trying to fool you and make sure that you get this problem wrong. But by doing it this way, you ensure that you did it correctly. And then if you count it on the sides, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Therefore, it is the perimeter is 5 plus 5 plus 5, which equals 15, which is also A. So the answer is A, 15. Problem 16. In the garden of a witch there are 30 animals, dogs, cats, and mice. The witch turned 6 dogs into cats and 5 cats into mice. Now the number of dogs, the number of cats, and the number of mice in her garden are equal. How many cats were there at the beginning? Now, at the end, we know that the amount is equal and there are 30 animals and 3 groups of animals. So each group of animals must have 10 in the end. And if we look at this closely, it says 6 cats are added and 5 cats are taken away, which means we add 1 to the cat population, which means the beginning value had to have been 9. Therefore, the answer is C, 9. Problem 17. With blocks of dimension 1 centimeter by 1 centimeter by 2 centimeters, you can build towers as shown in the picture. How high is a tower that is built in the same way using 28 blocks? Well, we have the options A, 9 centimeters, B, 11 centimeters, C, 12 centimeters, D, 14 centimeters, E, 17 centimeters. Now, we have to count these. So this has 3 blocks in it. This has 6 blocks. This has 10 blocks. This has 15. And you can see a pattern. Plus 3, plus 4, plus 5. So you would expect it to be plus 6 plus 7, right? 6 plus 7 plus 15 actually equals 28. Therefore, and if we look at this pattern closely, we see that these two are identical except you added 1 layer. So if we skip it 2 times, all you'd be doing is adding 1 more layer. And because they give you measurements and they want you to know how high the tower is, you can find that out because this is 2, this is 1, this is 2, this is 1, this is 2, this is 1, and this is 2. Therefore, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore, the answer is 11, B. Problem 18. Bridget folded a square sheet of paper twice and then cut it twice as shown in the figure. How many pieces of paper did she get? A, 6, B, 8, C, 9, D, 12, and E, 16. Well, if you look at this, she cut it 2 times like that. And if you mirror it over to this one, that would equal to a cuts like that. And if you mirror that over once more, that would equal to cuts like this. And then we count the amount of cuts that are on this square sheet of paper. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces of paper she is left with. Therefore, the answer is C, 9. Problem 19. Alex, Bob, and Carl go for a walk every day. If Alex doesn't wear a hat, then Bob wears a hat. If Bob doesn't wear a hat, then Carl wears a hat. Today, Bob is not wearing a hat. Who is wearing a hat? Well, if we look at this problem, since Bob isn't wearing a hat, that means Alex has to be wearing a hat. And since Bob isn't wearing a hat, Carl also has to wear one. Therefore, out of A, both Alex and Carl, B, only Alex, C, only Carl, D, neither Alex or Carl, E, it is not possible to determine, it is A, Alex and Carl. So, Alex wears a hat and Carl wears a hat. But Bob has no hat. Problem 20. Each of the following pictures shows the net of a cube. Only one of the resulting cubes has a line with connected endpoints drawn on it. Which one? A, B, C, D, or E? So let us first look at A. If you look at A, we'll pretend this is the top and these are the sides. If you look at it, the top and the sides won't line up because one of the points will be pointing away from it. So A cannot be the answer. B cannot be the answer either because these two squares will never meet. So B is not the answer either. And C is not the answer because these two endpoints will not face each other. So that is not the answer. D is the most likely answer, but let us check E to make sure that it is the correct answer. E is not possible too because these 2 points wouldn't be next to each other or wouldn't be facing each other to connect. Therefore, the answer is D. Problem 21. The cube shown in the figure has a positive integer written on each face. The products of the two numbers on opposite faces are always the same. What is the smallest possible sum of the 6 numbers on the cube? A, 36, B, 37, C, 41, D, 44, and E, 60. Well, if you look at it, we're pretty much trying to find the GCF, or greatest common factor. So if we're trying to find the greatest common factor, that would be 60 between all of these numbers. So 15, no, wait, that wouldn't be 60. It would be 30. So there would be 2 on this side. There would be 3 on the bottom. And there would be 6 to the side. So the lowest sum you can get if you add all of these up is 41, which is also equal to C. Problem 22. 6 identical black beads and 3 identical white beads are arranged on weighing scales as shown in the picture above. What is the total weight of these 9 beads? Well, if we look at this, 2 black equals 2 white plus a 6-gram weight. Therefore, for every one black, 1 black equals 1 white plus 3 grams. So, but we don't want to guess this out, so we go over to here. Now, we see here where it says 3 black and 1 white, it equals 1 black and 30-gram weight, which means if we take away one of these black beads, what we're left with is 2. If we took away 1 black bead from each side, we're left with 2 black, 1 white equals 30 grams. And then if we look at that, then each black would have to be 11 and each white would have to be 8. And then the question asks for the total weight of these 9 beads. So we multiply 6 by 11, we get 66, and 3 by 8, and we get 24. We add these together to get 90. So, therefore, the answer is E, 90 grams. Problem 23. Robert made 5 statements, A to E. Exactly one of these statements is false. Which one? A. My son Basil has 3 sisters. B. My daughter Anne has 2 brothers. C. My daughter Anne has 2 sisters. D. My son Basil has 2 brothers. And E. I have 5 children. So, if A is correct, that means there are 3 girls in the family. And if statement B is correct, then one of the daughters has 2 brothers, so there's 2 boys. And then that would make E correct. And that would also make C correct. Therefore, D must be the false one. Problem 24. Benjamin writes an integer in the first circle and then fills out the other 5 circles by following the instructions. How many of these 6 numbers in the circles are divisible by 3? A. 1. B. Both 1 and 2 are possible. C. 2. D. Both 2 and 3 are possible. E. Both 3 and 4 are possible. Well, if we look at for every 3 numbers you have a number divisible by 3. So, if you add 2, one of these 3 numbers is going to have to be divisible by 3. So that's 1 in our tally count. And then you multiply by 3, and that obviously makes it divisible by 3. So that's 2 on the tally count. But then you plus 2 and multiply by 2, and then both of those numbers are not divisible by 3. Therefore, there are only 2 possibilities, also known as C, 2. Problem 25. The cardboard shown on the right is folded into a 2 by 1 by 1 box. One of the pictures below does not show this box. Which one? So this is the outline of the box, and this is A, B, C, D, and E. So let's first look at A. A is possible because you're able to fold it so that it is possible to fold it that way, to have this on this side and to have it lining up like that. B is not possible, but we will look at the other 3 to make sure that B is the correct answer. Now we look at C, and we see C is also possible because it is possible to line these 2 up with that and have this and this on the side with this on another side. And for D is also possible because you can line this up with this and this. And E is also possible because you can possibly line these 2 up and create something like that. Therefore, the answer is B, because B is the only one that cannot be made from this outline. Problem 26. Emily took selfies with her 8 cousins. Each of her 8 cousins is in 2 or 3 pictures. In each picture, there are exactly 5 of Emily's cousins. How many selfies did Emily take? So, we'll just call all her cousins A, B, C, D, E, F, G, and H. So, we have A, B, C, D, E, F, G, and H. And we have to order them to make sure that each of them is in 2 to 3 photos. So, let's just start off by going by order. So, the first photo would be A, B, C, D, E. So, each of them has 1 now. And then we take it to the next one, which is F. We start with F. F, G, H. Now we have to go back to the beginning. So we put tallies on top of those. And then we have F, G, H, A, B. So then those both have 2 tallies. Then we go back around with C, D, E, F, G. C, D, E, F, G. And with C, D, E, F, G, we have to mark tallies for all of those letters which leaves H. So we have to go back around one last time to make sure every single person gets in at least 2. So we get H, add a tally, A, B, C, D. And in turn, we have, and then in turn, we have 1, 2, 3, 4 selfies that she made. So it would be B, 4 selfies. Problem 27. Jet and Willie are throwing balls at 2 identical pyramids of 15 cans. Jet knocks down 6 cans with a total of 25 points. Willie knocks down 4 cans. How many points does Willie score? Well, our options are A, 22, B, 23, C, 25, D, 26, and E, 28. So let us see. If we look at this closely, the ones that Jet has knocked down are, the 6 is still here, but she knocked down 3, 8, 2, 3, 4, and the top one. We don't know what the top one is because both of them have knocked it down, so we have to find out what the top one is. Well, 4 plus 3 plus 2 plus 8 plus 3 equals 20, which means that the top one has to be 5. So over here, we can see that Willie knocked down 5, but also knocked down 9, 4, and 8. So if we add 5, 9, 4, and 8, we get 26, which in turn also translates to D, 26. Problem 28. Every digit on my 24-hour digital clock is composed of at most 7 digital display parts, as follows. But unfortunately, for every digit display, the same 2 digital parts are not working. At this moment, my clock shows, what will it show after 3 hours and 45 minutes? Well, for this part, you have to make sure you get the right number of what you want out of this. So in this case, I thought that you needed a link that these 2 weren't working, so that if these 2 were working, it would show up as that, this, and this, showing 2347. So if I added 345 to this, then I would get 0, 3, 32. So then I look at these to see which one looks most like it and matches this. And I come up with A. A seems to match. If you look at it, it matches it with all of them. And it even matches up with the numbers. Wait. Oh yeah. So that's actually... So that would actually match up. Therefore, this would make sense. So the answer would be A, and even if we double checked all these, you would realize that none of these would make sense because none of them actually worked. Therefore, the answer is A. Problem 29. Linus builds a 4x4x4 cube using 32 white and 32 black 1x1x1 cubes. He arranges the cubes so that as much of the surface of his large cube as possible is white. What fraction of the surface of his cube is white? Well, if we look at this, there's an inner cube inside this cube of 2x2. And if we want as much white on the outside, then 2x2x2 equals 8. So 32 black minus 8 black, because we're trying to fit those inside, equals 24. And then we get 24 over 32, which equals 3/4. And the possibilities they gave us are A, 1/4, B, 1/2, C, 2/3, D, 3/4, and E, 3/8. So we see that 3/4 is indeed on there, and we get D. Problem 30. Seth has two machines. One makes one white token into 4 red tokens, while the other makes 1 red token into 3 white tokens. Zeph starts with 4 white tokens. After exactly 11 exchanges, he has 31 tokens. How many of those are red? A, 21, B, 17, C, 14, D, 27, and E, 11. Well, at first, let's say the amount of times it goes through machine 1 is X times, and the amount of the times it goes through the second machine is Y times. And then if we're satisfied with this, then we know that X plus Y must equal 11. Let me write that smaller. X plus Y equals 11. Okay, now we make a chart. So this is X, and this is white, and this is red. So if we begin with 4 white and 0 red, but then we slowly, this is beginning for B for beginning, and then we go to X and then Y. So if we look at X and Y, what do we get? So for X, for white we have 4 minus X, and for red we have 4X. For Y we have 4 minus X plus 3Y. And for this other one, we have 4X minus Y. Now we look at this, and then we take these two equations, simplify them, and then we get 4 plus 3X plus 2Y equals 31, as in 31 coins. And then once we're satisfied with this equation, we simplify it, and we get 3X plus 2Y equals 27. Now, we also have this equation and this equation. So, if we bind them together, we get 2X plus Y equals 22, and we get 3X plus 2Y equals 27. And if we solve for X and Y, we'll get X equals 5 and Y equals 6. But then we're finding out how many red are in the end. And if we get the red that are in the end, we need this equation, 4X minus Y. So we have 4X minus Y. And if we if we supplement the X and Y, then we get 20 minus 6 equals 14. And in this case, we know 14 is C, so the answer is C.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end.